In this lecture, we're going to talk about solving systems of nonlinear equations. We have several different methods of solving systems of nonlinear equations. The first, which we're not actually going to talk about in this lecture, is to graph both equations and find out where the graphs intersect. The second method is to solve the system using the substitution method. This method is most useful when the equations don't have the same variable exponent combinations. And third, we can solve the system using the elimination method. And the elimination method is most useful when both equations have the same variables with the same exponents. Let's start with an example where we'll solve a system using substitution. We're given the system of equations x squared minus y squared equals 21 and x plus y equals 7. So since the two equations don't have the same variables with the same exponents, we'll try the substitution method. We'll pick this equation that is easiest to solve, which would be equation 2. So equation 2 says that x plus y equals 7. We can solve this equation for y by subtracting x from both sides, so y equals 7 minus x. To use the substitution method, we'll substitute this result back into equation 1. So x squared minus 7 minus x, quantity squared, equals 21. We'll simplify by foiling 7 minus x squared, so we'll have x squared minus 49 minus 14x plus x squared equals 21. We'll distribute the negative sign throughout the parentheses, so we'll have x squared minus 49 plus 14x minus x squared equals 21. And then we'll combine our like terms. X squared minus x squared will cancel out, so we're left with 14x minus 49 equals 21. We'll add 49 to each side of the equation, giving us 14x equals 70. Then we'll divide both sides of the equation by 14, giving us x equals 5. Now that we know that x is equal to 5, we can plug it into equation 2 to find out what y is. So from equation 2, we had y equals 7 minus x, which means y will equal 7 minus 5. So y equals 2, and that means that the solution to this system of equations is the ordered pair 5, 2. Let's look at another example where we'll solve using substitution. This time we have the system of equations y squared minus x squared equals 9, and 2x minus y equals 3. So again, to solve using substitution, we need to solve one of the equations for one of the variables. So we'll pick the equation that looks easier to solve, that'd be the second equation, and we'll solve it for y this time. So if 2x minus y equals 3, and I solve for y, I would get y equals 2x minus 3. We'll plug this result into the first equation and then use that to solve for x. So our first equation was y squared minus x squared equals 9. If we plug in our result for y, we get 2x minus 3, quantity squared, minus x squared equals 9. We square the binomial by using the FOIL method. So 2x minus 3 squared gives us 4x squared minus 12x plus 9, and then minus x squared equals 9. We'll simplify by combining like terms. 4x squared minus x squared gives us 3x squared, so we have 3x squared minus 12x plus 9 equals 9. The 9's will cancel out from both sides of the equation, giving us 3x squared minus 12x equals 0, which we can solve by factoring. So we factor our quadratic out to be x times 3x minus 12. Then we'll use the zero product property, set each factor equal to 0, so x equals 0, or 3x minus 12 equals 0, and we'll solve for both factors. So we have x equals 0, and if 3x minus 12 equals 0, we'll get x equals 4. Now since we have two different values for x, we need to find out the corresponding y value for each one. So let's start with x equals 0. If x equals 0, using our previous result for y, we'll get y equals 2 times 0 minus 3, which simplifies to minus 3. And if x equals 4, we'll get y equals 2 times 4 minus 3, which is 8 minus 3, which is 5. So, this system of equations has two solutions. We have the ordered pair 0 minus 3, and the ordered pair 4, 5. Now let's look at some examples where we'll solve systems of equations using the elimination method. For our first example, we have x squared minus 3y squared plus 1 equals 0, and 2x squared minus 7y squared plus 5 equals 0. But just like with our previous systems of equations, to use the elimination method, we'll want to multiply one or both equations by a value so that when we add them together, things cancel out. So if I want to cancel out the x squared, I'll multiply the first equation by negative 2. So when we multiply the first equation by negative 2, we'll get negative 2x squared plus 6y squared minus 2 equals 0. We'll add the two equations together. Negative 2x squared plus 2x squared cancels out. 6y squared minus 7y squared gives us a negative y squared, and negative 2 plus 5 gives us a positive 3. So we get negative y squared plus 3 equals 0. We're going to add y squared to both sides of the equation, giving us that y squared equals 3. And then we'll take the square root of both sides to solve for y, so we'll have plus or minus square root of 3 equals y. So we have two potential values for y. We need to find the corresponding x values. So let's substitute our y values into the first equation to figure out what the corresponding x values would be. We'll start with y equals a positive root 3. If we plug that into our first equation, we'll get x squared minus 3 times the square root of 3 squared plus 1 equals 0. If we simplify that, the square root of 3 squared is 3, so we have x squared minus 3 times 3 plus 1 equals 0. Which means x squared minus 9 plus 1 equals 0. If we combine like terms, negative 9 plus 1 is minus 8, so we have x squared minus 8 equals 0. We add 8 to both sides of the equation to give us x squared equals 8. Then we take the square root of both sides of the equation to get x equals plus or minus the square root of 8. Finally, we can simplify this radical by rewriting the square root of 8 as plus or minus 2 times the square root of 2. So for the y value, square root of 3, we get two x values, 2 root 2 and negative 2 root 2. So now let's look at y equals negative square root of 3. If we plug negative square root of 3 into y in the first equation, we'll get x squared minus 3 times negative root 3 squared plus 1 equals 0. Negative root 3 squared is going to be a positive 3, so we get x squared minus 3 times 3 plus 1 equals 0. We simplify our multiplication to get x squared minus 9 plus 1 equals 0. Combine like terms to get x squared minus 8 equals 0. Add 8 to both sides of the equation to get x squared equals 8. Take the square root of both sides of the equation, so x equals plus or minus square root 8. And we can rewrite our radical as x equals plus or minus 2 times the square root of 2. So when y is negative root 3, we get two values of x as well, plus or minus 2 root 2. So there will be four solutions to this system of equations, and they are the ordered pairs, 2 root 2, root 3, negative 2 root 2, root 3, 2 root 2, negative root 3, and negative 2 root 2, negative root 3. Here's another example in which we'll use the elimination method. We have the system of equations x squared plus y squared equals 25, and 25x squared plus 16y squared equals 400. If we want to eliminate the y variable from the system of equations, we can multiply the first equation by negative 16. Doing so will give us the new equation, negative 16x squared minus 16y squared equals negative 400. And if we add our two equations together, negative 16x squared plus 25x squared gives us 11x squared. Negative 16y squared plus 16y squared cancels out, and negative 400 plus 400 also cancels out, giving us 0. So we're left with the equation x squared equals 0, which means that x equals 0 also. Now that we know that x is equal to 0, we can use it with one of our original equations to find out what y is. So if we start with our first equation, x squared plus y squared equals 25, we plug 0 in for x, that means 0 squared plus y squared equals 25. That means that y squared equals 25. We can take the square root of both sides of the equation, so y will equal plus or minus 5. So this system of equations will have two solutions, the ordered pairs 0, 5, and 0, negative 5. Let's look at one last example with the elimination method. This time our system of equations are x cubed minus 2x squared plus y squared plus 3y minus 4 equals 0. and x minus 2 plus y squared minus y all over x squared equals 0. So the first thing that we want to do, since we have an x squared in the denominator of the second equation, is we want to get rid of that fraction by multiplying everything by x squared. And we'll actually multiply by negative x squared. So if we multiply the second equation by negative x squared, when we distribute that throughout, we'll get the new second equation, negative x cubed plus 2x squared minus y squared plus y equals 0. Now we'll add our two equations together, and we see that x cubed minus x cubed cancels out, negative 2x squared plus 2x squared cancels out, y squared minus y squared cancels out, 3y plus y gives us 4y, negative 4 plus 0 is negative 4, so we're left with 4y minus 4 equals 0. We'll add 4 to both sides of this equation to get 4y equals 4, and then divide both sides of the equation by 4 to get y equals 1. Now that we know that y is equal to 1, we need to find the corresponding x values, so we'll plug 1 into the first equation for y, giving us x cubed minus 2x squared plus 1 squared plus 3 times 1 minus 4 equals 0. If we simplify that, we get x cubed minus 2x squared plus 4 minus 4 equals 0. And so that simplifies to give us x cubed minus 2x squared equals 0, which we can solve by factoring. We can factor an x squared out of both terms, giving us x squared times x minus 2 equals 0. And if we set both factors equal to 0, x squared equals 0 means that x has to equal 0, and x minus 2 equals 0 means that x would equal 2. So our corresponding x values are 0 and 2. That means that this system of equations has two solutions, the ordered pairs 0, 1 and 2, 1.